Before I start, I just wanted to acknowledge other member of my team who contributed in the analysis. Although I'm one who is presenting here, and also I would like to place my sincere thanks to you guys for this opportunity. My talk is a little different from the rest because I'm talking on the snow cover, whereas most of the presentations are on glaciers. Let me start with one slide on my office. I come from, I represent International Center for Integrated Mountain Development, headquartered in Kathmandu. We have 8 regional member countries, starting all the way from Pakistan, Afghanistan, India, Nepal, China, going down to Myanmar. So we have 8 regional member states. Our area of focus is Hindu Kush Himalaya. It is defined by this red or orange polygon here. And our institute is more of a regional knowledge and learning center. And information and knowledge is our main chief commodity that we try to fit into different national policies. We have just crossed over 35th anniversary of our existence. That there has been quite a lot of work that has been undertaken for the glaciers, but there has not been any work that has been done for the snow, and we need to start a snow cover activity as well. And then through this workshop, outcome of the workshop, we started analyzing snow cover area of all these 10 major river basins that I have shown. And for that, we have used a remote sensing approach, particularly taking the images from moderate resolution imaging spectrometer radiometer, generally called MODIS. This is what you see. This is a satellite system. MODIS is a satellite system, and ultimately that you will be able to get this kind of picture, this kind of satellite data from MODIS twice a day, one in the morning and one in the afternoon. And what you see here, the white, just all around this Himalaya is snow. And also what I wanted to draw your attention is all these white areas, which is actually a cloud. And particularly for remote sensing perspective, cloud really hinders our ability to map snow properly. And these images are present in 250 meter, 500 meter, and 1 kilometer spatial resolution. As I said, we get 2 images in a day of the whole Earth. And the snow cover that has been derived from this image is available at the 500 meter pixel resolutions. And that comes twice a day, one in the morning and one in the afternoon. That is actually already a NASA center where they have processed all these MODIS images to generate regular snow cover data. And that has actually been done in NASA's Goddard Space Flight Center. They produce or they generate for the whole globe snow cover at the 500 meter resolution every day. And then that's been pushed to one of the centers called NSIDC, National Snow and Ice Data Center there in Colorado University. And we had an arrangement with them to access the snow cover data of the whole Hindu Kush Himalaya on a regular basis. We have this FTP service established with them, and we used to download daily snow cover data every day in our server, and then we do some pre-processing of these snow cover data, and finally coming up with products which we disseminate each through our web portals as well as through physical means. But what you see here is, this is one of the examples of this MODIS snow cover data. But what you realize here is there are certain errors. There are certain errors that is actually inbuilt in the algorithm itself, and 2 of the major sources of errors are, one is cloud contamination, which I already demonstrated it, that in terms of remote sensing, cloud really hinders your ability to map, and which actually results in underestimation of the snow cover. The other one is misclassification. If you see here, this is the map of Bhutan, and if you see here, even in the south, they have mapped snow, which is completely an erroneous result. And these are because of the misclassifications of some other pixels as cloud, then that issue is with the algorithm itself. And that results in the overestimation. So there are two sorts of errors. One is underestimation, the other one is overestimation. And to handle this, what we did was we kind of implemented this algorithm to improve those products where we had, as I said, we do get images in the morning as well as in the afternoon. And this is, we compare, in the first instance, we compare these two products and try to improve the product. Second one is we use the 3 days products one after another and then compare the corresponding pixels and classify whether that what is under the cloud is snow or the non-snow. We also use a special filter for comparing neighboring pixels and pick up the correct value. And as I also showed you that there are certain pixels that has misclassified snow, and which is very obvious in the low altitude areas because you know that there is no snow. So we have used altitude-based threshold to eliminate those erroneous results. And then finally we arrive at something called enhanced snow cover products for the whole Hindu Kush Himalaya. This is example of the product that we have generated. The light blue is the snow cover and the gray is the cloud cover. And sometime in 2011 we published this report for the whole Hindu Kush Himalaya. This was launched in 19 or 17 somewhere in South Africa, Durban. This was the first actually comprehensive status of the snow cover for the whole Hindu Kush Himalaya. Now we are following up with this report and trying to come up with the second version of this report. The work right now I'm doing is again an update of that snow cover status. Again, we have taken snow cover data from 2003 to 2013, almost a decade long, and tried to analyze for the whole Hindu Kush Himalaya. Here you see all these 10 major basins as I showed you in the map, starting from Amu Darya and Tarim. Indus has the highest snow cover area, whereas Irrawaddy has the least snow cover area, and you can see the variation across all these major basins. If you see, the western and the central basins experience high snow cover in the winter. You can see this blue line which shows this winter snow cover area, which is more towards the western and the central area. But if you go towards eastern area, Salween, Mekong, Yangtze and Yellow River, we have the autumn snow cover becoming more dominant than the winter snow cover area. Talking about the trend, again, I want to start by saying that the trend that we have evaluated is statistically not significant. That has been a major problem in statistical analysis, which also has been expressed by my colleague here, Chimidoji. When you have a non-statistically significant results, that means that your result is just an indicative figure. It's not conclusive. So whatever the result that I am showing here is just an indication. Nevertheless, there has been some consistent finding as well. We have noticed that in the far eastern basin indicate positive trend. Here, if you see these red shaded areas are the negative trends, and if you see Mekong, Yangtze and Yellow River has an indication of a positive trend. Brahmaputra basin has indicated the highest rate of decline comparative to other basins. And all across the region, when we analyze the altitude-wise snow cover trend, we see that about around 3,000 to 4,000 meters above sea level, all across this basin, the snow cover is declining. In other areas, it is just there is a wide variability between each basin in other altitude range, but for 3,000 to 4,000 meter altitude range, it is consistent that the snow cover is declining. Snow cover across the aspect, there is a general tendency that most of the snow cover are distributed in the northeast and the southwest facing slopes. And also, if you see this, this one, the standard deviation of snow cover area from 2000 to 2003 to 2013, which indeed shows the variability of the snow cover. Again, here, the northeast facing slope has a higher variability of the snow cover compared to the other aspects. Season-wise snow cover area variation across the aspect. Again, here we have a little bit of variability towards, in all the seasons, towards bias towards northeast slope. This is the monthly average snow cover area from 2003 to 2013. You can clearly see here that in the far eastern basins, somewhere in Mekong, Salween, and Yangtze, the snow cover peak is somewhere near October and November. These are the graph. And for other west basins, the snow cover peak is somewhere between February or even late January to February. So there is this kind of variation between these far eastern basins and the rest of the basins. And higher monthly snow cover area availability noticed in the autumn and the spring months. You can pick up from this graph. If you see the seasonal variability, except for one basin, I think Yellow River, the seasonal variability is more during the autumn season, indicated by this orange covering graph. So in all the basins across this, except Yellow River, the autumn variation higher. This is another graph which we have plotted, snow cover area against the altitude. What this means is if you have a single line, you see that all these snow cover figures for all this region, all this year falls on the same point, but as you go down, you have this bifurcation of this line, which indicates that over this area, the snow cover has changed more. So what it means is, moment that you see the single line, you have less variability, but moment that you see a multi-line, then you have a higher variability of snow cover across all these regions. And what we can pick up from here is, it's about 5,000, 6,000 meters, the variability starts to arise below 5,000, below 6,000, around that, for most of the basins. Even here, if you see about 5,000 meter, 5,000, 4 to 6,000 meter, 5,000. It's at that elevation and below the variability of the snow cover is more over this decade. And above that, there is not much of variability. Again, same here, same. And now, this is one paper that I published in 2011, and we are listening to the snow cover statistics of Bhutan. I have taken up this sub-basin and basin. I have taken up data from 2000 to 2010. We see this is the mean snow cover area. So we have the Fortu has the largest snow cover area compared to other basins, and probably Ha has the lowest snow cover area compared to other basins. The change in snow cover area is not much, meaning that there is not much of melting that's happening in this period above 5,500 meters. And with the elevation, the snow depletion curve is changing, and also is being delayed. The melting time is also being delayed over the elevation. In terms of water availability, I think it's important that we need to look into the snow cover variability below 5,500 meters. It is very important for snow cover availability during the spring season when you really need water for agriculture. This is just an aspect in the snow cover area, and there's not much of a consistent design in this, but what I noticed here is probably in the spring, we have a much snow cover on the southwest facing slope. Probably to do with this winter contribution of the snow that comes through the westerlies. And what I also did was I compared. There was this data from this location automatic weather station right up there in the Lunana area. And I compared this temperature here with the snow cover area for the Pochu, and it reveals there's a very strong correlation between the temperature and the snow cover area for this Pochu basin. So there needs to be a concern with the rising temperature. There needs to be a concern to address the snow cover variability as well. To conclude, I have not read each one of these, but I just wanted to highlight that there is a very limited research done on the snow in the southern face of the Himalaya, and there is very few stations alpine at the alpine area, alpine belts. I think we probably have around 3 at the most right now in Bhutan, above 4,000, 4,500 meters, where actually we really need to have as many as stations if we really need to understand the glacier dynamics, snow dynamics, and the climate as a whole for the alpine belt. Thank you for attending.